Okay, well, hello and welcome. Um, Come again with another YouTube video, and this time I have taken a problem which is, I believe, fairly simple, and there is nothing special about the problem, but a bit about the solution that I thought that I should share. And so the problem goes on the lines of something like this: that A and B are real numbers and satisfying this equation, and then we're supposed to find the minimum value of this expression. Well, one way to solve this problem is obviously you can use algebra, and I'd recommend you to do so. Well, let me try to use some geometry to solve this problem. So to solve this problem, I'm going to switch to sort of a new system of defining distances, and it's non-Euclidean, if you like. So distance between points x1, y1 and x2, y2. Say define that as x2 minus x1 plus mod of y2 minus y1. All right. And well, obviously we can define so that this idea shouldn't appear scandalous. In fact, this is the first norm, and pth norm can be denoted something like that. That this is x2 minus x1 to the p plus y2 minus y1 to the p and to the 1 upon p. That's the pth norm. So there's just L1. So mod of x2 minus x1 plus mod of y2 minus y1 effectively. So first of all, before I go ahead and solve this problem, let's try to sort of make ourselves comfortable with a new idea of distance. This distance between 2 points. So for example, say that you're standing here at origin, and here is a point 3, 4. So, well, the distance between origin and 3, 4 is no longer 5 units. It's in fact, well, 3 plus 4 units. So there's the distance between 0, 0 and 3, 4. And in fact, that's also called sometimes the taxicab distance. And that's simply because think about it, that if you were going in and around avenues and streets. So suppose that these are streets and these are avenues. So in order to reach from here to here, and this is what you'll have to do. You'll have to go from this point to this point and here. And no matter even if you don't go from this point to this point, and if you're talking about the shortest distance, you will have to travel at least this much. You can possibly fly like this because streets are not designed that way, right? So that's the distance. And suppose that if I were to ask the distance between well, something like minus 10, minus 10 and 3, 4, well, this distance is going to be this and plus this. So that's a fundamental idea of distance, right? So which brings me back to the problem. The problem says that, well, you have to find numbers such that mod of a minus 1 plus mod of b minus 1 is equal to mod of a plus mod of b is equal to mod of a plus 1 plus mod of b plus 1. Left hand side is fundamentally the distance of point a comma b from the point 1, 1, as you can see. And this whole thing is fundamentally the distance of the point a comma b from the origin. And this whole thing is fundamentally the distance of point a comma b from minus 1, minus 1. So if you look at it, we're just looking for distances between a comma b and 0, 0 and minus 1, minus 1. And these distances should be equal, right? So let's make this nice little square. Okay. And first observation would that be that if you're going to find a point which is equidistant from these 3 points, and distance is measured as such that it's the total number of units that you have to go on x plus total number of units that you have to go on y. That's the distance. So it's kind of obvious that the point isn't going to lie in the first quadrant. And that's simply because any point lying in the first quadrant will be closer to the origin than it will be to -1, -1, because of the simple fact that, well, this is going to be larger than this. It's almost trivial, isn't it? Since the point can't lie in the first quadrant, so the point can't lie in the third quadrant. It's kind of obvious again. Right. So the point either should lie in the second quadrant or the point should lie in the fourth quadrant. You can notice that this point 1, -1 is one such point. And similarly, by symmetry, this point -1, 1 is another one such point. That it lies equidistant from these 3 points, right? So that's the thing. That's about it, right? And so now, if you look at it, so looking at this equation, so what we know is that, well, this point is kind of equidistant from this point and this point. Why? Because, well, this is 2 units, this is 2 units, and from origin there's 2 units, right? So this point must be one such point. Now, it's almost trivial to see that any point which lies in this region, any point which lies in this region is not one of those points that you're interested in, and that's simply because its distance from origin is not going to be equal to its distance from 1, 1. And that's simply because, well, this part here is common. This is 1 unit distance, and this is not 1 unit. So and any point lying here will not satisfy this, right? Because it's not equidistant from origin and this. So, well, again, using symmetry, we can argue for this part, we can argue for this part and this part. Notice that 1, -1 satisfies, and even if there is a point which lies in this region and which is equidistant from these points, even if there is one such point which is equidistant from these 3 points, what usually happens is that you'll see that, well, it just so happens that for this point, mod of a minus b is going to be much more than any point lying in this region for 1, -1. Why? Because if you go down, or if you go down and right, you increase x and y, and therefore mod of x minus y increases. And since there was no point lying here, and we have already argued that, well, if you go here or anywhere in this region, you're going to increase the value of mod of a minus b. So this is the point for which the value will be minimum by symmetry. By symmetry, the other point will be -1, 1, and so on and so forth. Same arguments can be used for other regions by symmetry. So the point is either 1, -1 or -1, 1. And it's almost trivial to see that both these points satisfy the given equation, and hence the minimum value is a minus b is 2. And we are done.